Okay, so the fourth person hasn't come yet, so let's just start the class now. Okay, so here's the where did all this come from? Okay, so here's the homework from last time. These are the 4 questions I wrote. So first, calculators were allowed, but please keep your answers somewhere. Ooh, okay. Hi, Jason. Wait, where did he go? Hi, Jason. Okay, so we just started talking about the Math Kangaroo homework. So these were 4 questions. And also please keep your answers somewhere so that we can go over it next class. Okay, so first, let's start with question 1. The shape is to be split into 4 identical pieces. What would be the shape of the piece? Okay, so here we see it looks like 3 2x2s glued together. And we're trying to find 4 pieces that it could be split into. Okay, so let me open up a oh, someone raised their hand. Do you have a question?
Where did you put the homework? I didn't see it.
Oh, I put it in the WeChat. I'll just send the link right now. Here's the link. Okay. So let me show a whiteboard. And so there's a shape that looks roughly like this. Okay, so a shape looks roughly like this, and what we're looking to do is to split this into 4 equal and identical parts. Those 4 parts, they can be rotated and moved around, but they still have to be the same original shape. So first let's find how many squares would be in each of these parts. So there are 12 squares total, and we have to split this into 4 squares, so there's 3 squares in each shape. So there's not a lot of different ways to make combinations of 3 squares, so let's first draw these out. We have the 1 by 3, we can have the 3 by 1, or we can have the L shape, which looks like this. I don't think there's any other way that we can have connected shapes. We could have something that looks like this, but that wouldn't be very useful because none of the blocks are connected. So we'll just remove this. So we can either have the line or we can have the L. And if we try out the line, I'll just use the stamps. So the stamps check mark for the first 1, 2, 3. We can have a line like that. We can have a line like this. We can have another line like this. But then we have an L left over, so we can't do that. And if you keep trying and trying to rearrange the L's, you won't find any way to do that. Then trying to rearrange the lines. So if we take the L, let's just put an L here. We can have another L here. And then we can have 2 rotated L's here and here. And that fills up the larger shape nice. So The answer is the L shape. 3 squares of an L shape. Okay. Let's go back to the problem set. So for number 1, it would be an L shape. Okay, so now to the second one. There are 3 blue blocks and 1 red block. How many ways can they be put in a row? All the blue blocks look exactly the same, so you cannot tell them apart. Okay. Is annotate working? Yes, it is. Okay. So we have 3. Let's put the 4 blocks in a row, and then we'll decide the color. We must have 4 blocks in a row because that's how the problem is set up. And for a blue block, we'll just do the question marks because they're blue, and for the red blocks, we'll do an X. How many ways can they be put in a row? Let's first start with the X because there's less of the X's. We put an X here, and we put blue blocks for the rest. That's one way. And then the second way, we can put an X here, and we put question marks all around. Or we can do the third way, which you put an X here, and you already know the rest. You fill in the rest with a question mark. And the fourth one, you put an X in the last one, and you fill in these first 3 with a question mark. And there's no other ways to do it, so in total, there are 4 different ways. For problem 2, the way to do it is you can just guess. So this is a pretty simple problem. And also, all of these are based off problems that are in the original competition. Okay, so for problem 2, there are 4 ways. Alright. So problem 3, there is a 4x4x4 cube made out of 64 unit cubes and is dipped into paint, then taken out and disassembled. How many cubes have no paint on any side? Okay, so let's make another drawing for this one. Let's first cover up the 4th problem. So we have a 4x4x4 cube. That would look like this. Then you'd have lines going here. And then you'd have lines going across. That split each face into a 4x4 square. And then you make that into a 4x4x4 cube. Okay, so our first one would be to find how many squares are covered in paint, but that would be hard to count. So let's just count the way that the problem told us to by counting the number of squares not covered in paint. So there are 4x4x4, and if we look inside the cube, we can imagine the cube as a frame. So a frame, only the edges and the corners are left, and the centers are gone, and the very center is gone. In the very center, there is a 2x2x2 cube, which is surrounded by these 2 edges and these 2 edges. So there's a middle 2 layers. But then the middle 2 layers is also surrounded by paint, so we take off the top 2 layers. Then we have a 2x2x4 cube, by 4 rectangular prism. And then the last 2 faces are also covered in paint. The 2 faces that were still on the outside. So remember to remove that 2x2 and this 2x2, so we end up with a 2x2x2 in the middle. And we all know that a 2x2x2 we know that a 2x2x2 cube, the volume is equal to its length times width times height, which is 2 times 2 times 2, which is 8. So the answer for problem 3 is 8. Cubes. Okay, so problem 4 Also, problem 3, this requires some visualization, trying to visualize the problem in your head, which is very important if you want to do well in these math competitions, since there are a lot of geometry problems similar to this. Okay, so problem 4, there are 10 balls, each numbered 0 to 9 in a basket. John and George play a game. Each person is allowed to take 3 balls from the basket and calculate the product of the numbers of the balls. What is the biggest possible difference between John and George's totals? This is based off a problem from last time where this product here is replaced with a sum. Now we switch to a product, and let's do this problem. So you have 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are the numbers you can choose, and you have to multiply them to find the largest difference between the largest number and the smallest number. So naturally, we would take the 3 smallest numbers and the 3 largest numbers. You multiply these together, so 0 times 1 times 2 is equal to 0, because 1 times 2 is 2, and 0 times 2 is 2. Then we take the 3 largest numbers and multiply them. 9 times 8 times 7 is equal to 504. And you can use a calculator for this, because this might be hard to do on paper or meant to be done mentally. So you have the largest number and the smallest number that you can get from multiplying 3 different numbers. So here, your answer would be 504, the largest number, minus 0, the smallest number, which is equal to 504. And so for problem 4, the answer would be 504. Okay, so this problem, you need a good understanding of problem solving to do problem 4, because it's looking for a difference, and a difference is equal to one number minus the other number. And if you want the largest difference, you have to subtract the smallest possible number from the largest possible number, which is how you would do this problem. Okay, so we're done with the homework. Let's switch over to this time's problems. We're doing the last 5 questions again. This is the 2016 third to 4th grade problem. Also, what do all of you think about this problem? You can either type it in chat or just say it out loud. Is it too hard, too easy, or is it alright? Is this problem set hard? Okay, so since I didn't get any feedback, I'll just make the next problem set of an equal difficulty to this, so not too hard and not too easy. Alright, so let's move on to these problems. Okay, so our first problem is, we'll start with 24 and work our way down to 20. 5 sparrows on a rope look in one or the other direction. See the diagram. Every sparrow whistles as many times as the number of sparrows they can see in front of them. Therefore, Azra, which is the furthest left, whistles 4 times. Then one sparrow turns in the opposite direction, and all sparrows whistle according to the same rule. The second time, the sparrows whistle more in total than the first time. Which sparrow has turned around? Okay, so what this problem means is that each bird is looking in one direction, and all the birds they can see in that direction. For example, Azra can see Bernard, Krista, David, and Elsa. So they whistle 4 times, which is equal to the number of birds they can see. Bernard can only see one bird, which is Azra, so Bernard whistles once. Krista can see 2, David and Elsa, so Krista whistles twice, and so on. Okay, so we are finding the premise is that all the birds whistle, and then one sparrow turns in the opposite direction. So if they were looking to the left, they turn right, and if they were looking to the right, they turn left. and then they whistle again. So, and the problem is, if the second time the birds whistle more than the first time, which sparrow has turned around? Okay, so let's find how we can increase this number. Azra whistles 4 times the first time, and then they whistle, and if they turned around, they would whistle 0 times. So on the top, we will write how many times they whistled the first time, and we will find how many times they whistled the second time. And we will find the one that has the greatest difference, or the one that would increase the number of whistles if they switch direction. That would be the one that turned around. Okay, so Bernard whistles once the first time, and if they turned around, Bernard would see Krista, David, and Elsa. So that would be 3 times. Krista currently sees two, and if Krista turned around to look at the left, Krista would see Azra and Bernard, so that would be 2 times. David currently sees 3, and if they turn around, would see 1. Elsa sees 4, and if they turn around, they would see 0. So whichever one has an increase from top to bottom would be the one that turned around, and the only one that has an increase and does not say the same is Bernard, starting at 1 time, and if they turned around, would whistle 3 times. So for 24, the answer is B. Okay. Okay, let's go to problem 23. Leo has a stick made of 27 building blocks. He splits the stick into 2 pieces in a way that one part is twice as long as the other. He keeps repeating this again and again. He takes one of the 2 pieces and splits it up so that one piece is twice as long as the other. Which of the following pieces can never result in this way? Okay, so let's just figure out a way to determine the length. So he has a stick of 27 pieces, and if you split it into 2 pieces where one is twice as long as the other, that would split into 9 and 18, because 18 is 2 times 9, and there's 27 total building blocks. So the first stick has 9 pieces, and the second stick has 18 pieces, so in total they have 27, which is equal to the original. Let's do the same for the one with 9. Okay, so 9, if you split it in half, where one is twice as large as the other, the smaller one would be 3, and the second one would be 6. Okay, so, and then if we split the 18-piece one, we'd end up with a piece that is 6 in length, and a piece that is 12 in length. Okay, let me move this a little further down. And then if we continue splitting it, we'd have a piece that is 1 long and 2 long. The 6 would go to 2 long and 4 long. This other 6 would go to 2 and 4. And the 12 would go to 4 and 8. And all of these you can check, it's correct. So 8 is 2 times 4, and they both add to 12. So which of the pieces can never result in this way? And it's also helpful that on the bottom they show the length of these. Alright, so let's find the numbers here that don't show up at all on this chart, which is all the possible ways that you could split the sticks. 2 shows up on this chart multiple times, 4 shows up on this chart multiple times, 6 shows up on the chart twice, 8 shows up once, but 10 never shows up. So 23, the answer is E. Here for 23, you just have to be organized. And if you're organized, you can easily get the question correct. Okay. So now we're doing problem 22. Eva writes 7 numbers on a piece of paper, one of which is 201. She adds up these 7 numbers and gets 2016. Now she substitutes the 201 by 102 and then adds up the 7 numbers. Which result does she get now? Okay, so if we added up the total, we have 201, and there's 6 other numbers, which we'll write as number 1, number 2, number 3, number 4, number 5, and number 6. So that's 7 numbers total. And we could do a nice little trick here. We would just replace all of these with 1, or whatever's easy, perhaps 0. So 201, oh, and she gets 2016, so 201. We can do 0, 0, 0, 0, 0. And then for the last one, we can do 2016 minus 201, which is 1815. And here's why we can do this. If they don't give any specific numbers, that means that all numbers are possible. Unless they say that not all numbers are possible, we can just put 0, 0, 0, 0, 0. And you can do this just to make all the problems a lot easier so that you don't have to introduce variables. Variables are just used to replace numbers. Okay, so we have 201, 5 zeros, and 1815. What? Okay, so the total sum is equal to 2016, so that checks out. If we replace the 201 with a 102, we have 102, 0, 0, 0, 0, 0, and 1815, which is again using our trick that if they never said what the numbers have to be, that means they can be anything. And we add these all together, which ends up equal to 102 plus 1815, which is equal to 1917. And that's one of the answers, and it's 22. For 22, the answer is C. Okay, so that was pretty easy. For here, you just use the simple trick that if they never say anything, you can assume that anything is correct. Now to 21. Karen wants to place 5 bowls on a table so that they are ordered according to their weight. She has already placed the bowls Q, R, S, and T in order, where Q is lightest and T is heaviest. Where does she have to place bowl Z? Okay, so we're ordering these from lightest to heaviest, and all the triangles have the same weight, all the circles have the same weight, all the squares have the same weight, and the trays have the same weight. So what we can get now is we can just put the weight of a triangle as T. So the weight of Q is 2T plus S, where S is the weight of the square. Here we have 2C plus S. We have 2S plus T. And we have 2S plus C. And then we can do this by to just express the weight. So first we have Q and R. If 2C plus S is greater than 2T plus S, then that means 2C has to be greater than 2T, where C is, and also C is greater than T. So C is greater than T. And this arrow is just used to denote which is greater and which is less. Okay, so then we can go up to S and Q. Here we can just subtract. So S minus Q has to be greater than 0 because S is larger than Q. That means 2 small s plus T minus 2T plus S is equal to S minus T, which has to be greater than 0. So S minus T is greater than 0. Which also means that S has to be greater than T. So far we have C is larger than T, S is larger than T. Now we just have to see which is larger, C or S. So Let's go on to the next one. We can find the ones that only use S and C, which are R and T. So T is greater than R, so T is heavier than R, so the total weight of T minus the total weight of R must be greater than 0. So 2S plus C minus 2C plus S is equal to S minus C, which is greater than 0. And we have S is greater than C. So we have S is greater than C is greater than T. And now we can just substitute random numbers. We can say T is 0, C equals 1, and S equals 2. And now we can just assign weights to all of these. If T is 0 and S is 1, then the weight of Q is 1. If C is 1 and S is 2, then we can just put the weight of R as 4. Oh, did you raise your hand? Do you have a question?
Could we say what we think the answer is?
Sure. So, what did
I think that the answer is to the between both Q and R.
Okay, so you got B. Does anyone else want to share what they got for the answer? If not, I'll just continue. So now that we have the weights of each of these, we can just add these up. So 2S plus T is equal to 4 plus 1, which is 5. So the weight of S is 5, and the weight of T is 2S plus C. Wait, S is not... S is actually... This is actually... What? Okay, so let's redraw this. Q is 2T plus S, which is 2. R is 2C plus S, which is 4. S is 2S plus T, which is 4, and T is 2S plus C, which is 5. And then we have Z, which is triangle plus circle plus square, which is equal to 0 plus 1 plus 2, so the weight is 3. And the numbers that are greater than 3 and less than 3 are 4 and 2, which are R and Q. So that means that Z has to be between Q and R, so U is correct. The answer is B. Okay, so for 21, here you just get a system of inequalities. We find which boxes are heavier than which circles, and which circles are heavier than which triangles. And once we have the weights of each of these, we just make up random weights as long as they follow which ones are heavier. Then we can figure out the answer from there, and it's rather simple. Okay, so problem 21 is done. We do not have time for problem 20, so we'll stop here. And the homework will be the same document. So save this document link. If you want me to send it again, I can send it. I'll also send it in the WeChat. And I'll say in the WeChat when I've updated the questions. So when I update the questions, you can just go onto the document and you'll see a new set of questions to do. Okay, does anyone have any questions? If not, then I'll just end the meeting. Colin, do you have a question? Jason? Wu Yang?
Nope.
Okay. Okay. Bye, everyone. I'll end the meeting now.